Factoring polynomials. So we're going to talk about factoring, the basic techniques or basic concept of factoring, right? Factoring, well, I guess you can think of factoring as in many different ways, but one of the concept of factoring that you can think of would be backward multiplication. Backward multiplication. What do I mean by that? Well, let's say you multiply x to x plus 2, right? Multiply this x to here, which is x squared. You'll multiply this x to 2, which becomes 2x. So process from here to here that we call multiplication. Now what we try to do now, we're going to start from here and go back to this stage. Right? That's factoring. So one of the technique to factor is to break it down to smallest possible pieces. So let's say we have x squared plus 2x. You break it down this x squared as x times x, and this 2x as 2 times x. And now you're comparing this term and this term. Now, do we have any common factor, common term factor that you see from this and this? Well, we have x here and we have x there, right? We have this same x term. So the proper language that they are using is that you are factoring out those common terms. So I'm going to factor out the x, this, and this. Because I factored it out, I'm going to put the parentheses and then write whatever left behind. So if I factor x out, there's still this x left behind. What's the linking operation? Linking operation is plus, because we have plus there. What's left behind from this once we factor x? Well, 2. Just like that. And that result is factoring. See this? From here to here, multiplication. From here to here is factoring. So I guess that's one of the basic concept of factoring. One of the basic concept of factoring. I guess the next question that we should ask is that why do we factor? I mean, what's the purpose of factoring? Well, there are many different purposes for factoring. One of the reasons for factoring is to identify a solution in a simpler, easier way. So, you know, let's say we have x squared plus 2x equal 0. Let's say we have this equation and we try to solve this equation. What do I mean by solve this equation? Well, we'll try to identify particular x value that we're going to put it here and here that equals to 0. Now, just by looking at this, you can kind of see that x equals 0 is your answer. Because if you put 0 there, that's going to be 0. And if you put 0 there, that's going to be 0. So, 2 0 added, still 0. But we know there's another answer. Well, possibly there's another answer. What would that be? Well, this one is simple enough to see that another answer is negative 2, because negative 2 square becomes 4, right? If you put negative 2 here, then becomes 4. If you put negative 4 there, 2 times negative 2 becomes negative 4, right? If you replace this. So you have like 4 minus 4 equals 0. Check. That works. But, we also checked when we factor this became x times x plus 2, right? And equals 0. So this equation right here and that equation right there look different slightly, but yes, they look different. But they are the same equation, You can see that this equal this, right? They are the same equation. So when we try to identify x value, when we try to solve this, what value of x equals 0, if we take a look at this, then figuring out solution in here and figuring out solution in here is the same thing. And this might be easier because look at that. That's a multiplication. By the nature of multiplication, if one of them equals 0, when you multiply, it becomes 0, right? So right here, we know that x equals 0 would be one of the solution answer, because 0 times whatever equals 0. Another solution would be whenever that equals 0. So when do we have the x plus 2 equals 0? X plus 2 equals 0, x equal negative 2, right? So that's another solution with these two solutions right away. So, if you have equation like that, not too crazy complicated, but totally easy to figure out. But if you put it in factored form, it's even easier to figure out the answer. And sometimes the original equation that we try to solve is not that simple, not that easy. But once we factor it, then it's a lot easier to figure out the solution. So factoring serves many purposes, but this is definitely one of the reasons why we should factor. Now, factoring, fortunately, unfortunately, involves with formulas. I mean, why is it fortunate? Because if you know the formula, then you can apply it. You can get the easy answer. The unfortunate part is that you have to memorize the formula, and you have to know the formula in order to actually apply. But once you memorize and you know how it works, then you don't actually have to carry out a lot of calculation in order to get to the answer, right? So here's some formulas that I rather want you to memorize. So the first one would be x squared minus a squared. So, if we have x squared minus something else square form, this will be factored as x plus a, x minus a, right? Oh, what do you mean by this? Well, if I just give you a quick example, let's say if you have x squared minus 9, can we factor it? I mean, if we try to apply this previous technique of dividing whatever given into a smaller factor, this will not work. If it doesn't work, because if you factor this, this would be like, this is side note. This would be like x times x minus this 9 can break down to 3 times 3. There's no common factor. So what do? You say, oh, this is not factorable. But that's not the case. This is factorable. So if you recognize this as x squared minus 3 squared, because 9 is 3 squared, that's exactly in this form. So our x is x. What's our a? Our a is 3. Then what's the answer? Answer for this would be x plus 3 and x minus 3. That's our answer for this factoring question. But you can get this answer very easily if you memorize and understand this formula, right? If you memorize and understand this formula. Another formula that we should also know is x squared plus 2ax plus a squared. If an equation is in this form, it will be factored as x plus a to the square, also known as perfect square. Now, we mentioned this and this in our previous lecture, right? Similar pattern, this would be minus here now, 2ax. This is plus right there, a squared. This would be factored as x. What would this be? Plus or minus? Minus, that's right. Minus a squared, like this. So if that's a plus, everything plus, then that's a plus. If this is a minus right there, then that's a minus right there. Yep, that's a plus, right? So again, example of this would be something like this. Let's say you have x squared minus 6x plus 9. Again, if you use the initial technique, breaking down to smallest pieces factor, that's not going to work. But if you understand this formula, and if you can see that this given equation is actually in one of this form, see, this is x squared minus 2 times 3, because this 6 is 2 times 3, and this is 9, so this is 3, well, I forgot the x, 2 times 3x plus 3 square. If it's in that form, that's same thing as this, right? X squared minus 2ax plus a squared form. This is the exact same form. Then what should be the answer? The answer for this factoring question is this. So it will be x minus, what's our a? Our a is 3 squared. That's our answer right there. I mean, in the beginning, that's not really easy to see. How do you supposed to see this into this format? Because how do I know that I supposed to break this 6 down into 2 times 3 and 9 into 3 square form? You just show me so I can see, but I don't think I'll be able to see this right away like that, right? Probably some of you think like this. Well, I guess there's no short answer for that. You need to do a lot of practice. For me, it's so natural to see this into this. Why? Well, at least there's several reasons, but one of the reasons is that I've done this for at least 5,000 times, right? So for me, it's when I see 9, I see 3 square almost at the same time. I see 9 is here, right? But I see 3 square almost at the same time because uh, because of those repetition, my brain um, is wired in that way. You know, if you so what I'm trying to say is that you need to do a lot of practice on similar kind, then it'll be also natural for you to see this into this. Another tip is that if you recognize this format, x squared, x, and the number, and the last number right there should be something to the square form. So it should be a nice number like 9, 3 square, or 4, which is 2 square, or 16, which is 4 square, or 25, 5 square and 36 and so forth. So if this was like 8 or 7, which is not one of those square number, then I wouldn't think this way. I'll try to figure out some other technique. But since this is a 9, it gives me opportunity to think this as 3 square. Oh, if this is 3 square, is that 2 times 3? That's what I'm checking. Oh, this is 6, 2 times 3. Oh, then I can apply this formula, right? So that's my thought pattern, right? So it's not that easy, but once you get it, then you'll be able to use it, right? Then go straight to the answer like this. Another formula would be perfect, the previous formula of perfect square now is sum of 2 cube or difference of 2 cube. Well, the formula looks like this. Let's say you have x to the cube plus a to the cube, like this. Then this will be factored as x plus a and x squared. Now this is the important part. Minus ax plus a squared, like this. Right? If this is a plus, only minus is here, right there. In the same way, similar way, the cube minus a to the cube equal. Now if that's a minus, then this would be x minus a, and everything else is plus x squared plus ax plus a to the square. So this is another weird case. But if you recognize this format, that equation will be factored like this. So let's say x to the cube, it has to be cube, minus 8. Example, right? This is example. Then, in the beginning, at first, it's not easy to see 8 as some numbers to the cube, but if you do this many times, then you know that 8 is 2 to the cube, right? 2 times 2 times 2. Then I'm trying to figure out, oh, then this is in this form, right? X squared minus a, which is 2 to the cube. Then I can factor this as x minus 2, x squared plus 2x plus a squared, 2 squared, 4. Just like that, right? So, I mean, what do I do if I don't remember this formula? How do I factor this into this? Well, at this stage, you cannot. So, if you do not memorize this, then you cannot do this. Simple as that. But if you memorize this and recognize this pattern, then you can get to your answer almost like mechanically, right? Almost like mechanically. Another example, same kind, would be x to the cube plus 1. Now this is like common trick. See, I need something to the cube in order to apply this. But this is just 1. Well, the good thing about 1 is that 1 times 1 times 1 is still 1. So you can think of this as x to the cube plus 1 to the cube. Then what do? We can rewrite this as what's our a this time? I'm going to apply this formula, right? This formula, because it's in that format. All right. Well, I don't like that line. So this would be x plus our a is 1. So x squared minus 1 times a times x. 1 times x is just x plus 1 square, which is just 1. So that's our answer. Right? So in this video clip lecture that we learned, a little bit of the basic principle of polynomial factoring, and we checked a couple of formulas and application of those formulas, right?